Hello, in this video I'll be showing you how to find the vector product of two vectors, or otherwise known as the vector cross product. So what I mean by this is basically if you have two vectors, right? You have a vector, let's say vector A, and you have a vector B. And basically what you do when you want to find the cross product, the cross product produces a vector that's perpendicular or orthogonal to both of them. So it produces some vector, let's say R. So the cross product, we denote it by using A cross with B produces this vector R. Okay? Now the way you do them determines which direction this R vector goes. So if you have A cross with B, you're going to get the vector R, which is in this direction here. But if you do the opposite way, so if you do B cross with A, you're going to get this vector down here in the opposite direction. So you're going to get negative R in this case. Alright? So those are some good notes for this topic. So this is the vector cross product. So when you cross two vectors, you get a vector as a product. Now, what is this basically used for? It's used in applications of physics. It's used to find the work of certain things. And basically, the way we do cross product is we denote using a times symbol or an X. Note there's two types of products you can have. You can have the vector cross product. So this is the vector product. When you cross two vectors, you get a vector. You could also have the dot product, which produces a scalar. Okay, so this produces a vector, and this produces a scalar. Right? In this video, we're just focusing on the vector product. Now, how do you actually find the vector product? Well, we start by writing vector A cross with vector B. And basically what we do is find the determinant of a 3 by 3 matrix. Okay? So the way we do it is, since we're dealing with vectors, the top row has the vector components in the x, y, and z direction respectively. So I is our x direction, j is our y direction, and k is our z direction. And then what we do is we put the components of vector A in this row here, and the components of vector B in this row here. Okay? So what does that actually look like? So that looks like this pretty much. So you take the x component of A, so let's say A1, the y component of A, so A2, and the z component of A, so A3. Okay? And then you do the same with vector B. So let's say we have B1, B2, B3. Now this is a 3 by 3 matrix. Now the reason we have these brackets here, like they're straight up rather than being curved or squared like a normal matrix, basically what this symbolizes is determinant. So the way we find the determinant of a 3 by 3 matrix is basically it's a pretty it's an algorithm process pretty much. So what you do is, alright, we've got to find the x component, the y component, and the j component, because we know that if A cross with B, that's going to produce a vector R. So what do we do? So to find the xi component, what we do is we cross out the first column and we cross out the first row, and we write a little 2 by 2 matrix here. So we just say this is equal to the determinant of this 2 by 2 matrix, so A2, A3, B2, B3, and since this is in the x direction, we put our little I here. So that's our first one. Now we got to find the j component. So we're going to do the exact same thing. We're going to cross out the first. We're going to cross out the j row and the top row. Okay. So now we're going to find the determinant of this 2 by 2 matrix. Now, if you're finding the determinant of a matrix, you generally have this pattern. You have plus, minus, plus, minus, plus. So now we're going to have a minus here, and to find the determinant of this matrix here. So A1, A3, B1, B3, and that's J. Okay. And then we're going to do it for the final one. So we're going to cross out the K column and the top one here. And then find the determinant of this 2 by 2 matrix here. And we're going to follow our same pattern up here, plus, minus, plus. So it's going to be plus the determinant of A1, A2, B1, B2, K. Alright? And that's pretty much how you cross product them. Now, before you're able to solve, we'll find the determinant of these, you need to know some basics of determinants of a matrix. So to find the determinant of, let's say, a 2 by 2 matrix, so you have A, B, C, D. So if you want to find the determinant, let's say this is matrix A, and you want to find the determinant of A, how you calculate that is basically A times D minus B times C. Okay? If that's in this general form here. Okay? So all you got to do is basically apply that to every little 2 by 2 matrix here. So what does that actually look like when we evaluate that? So I'm just going to move all this a bit higher so we have enough room and make it just a tiny bit smaller. So let's evaluate this matrix here. So the determinant of this would be A2 multiplied by B3, subtract A3 minus B2, put that all in brackets with an I, and they'll give out some random number I, okay? And that's our X component of our vector product. Then we gotta find the determinant of this matrix here. Now we have a negative sign at the front, so we can't forget that as well. So what we do is negative brackets, then you find the product of A1 multiplied by B3, subtract the product of A3 multiplied by B1, brackets, brackets, J. And they'll give you some scalar, and they'll be our Y component. Okay? Now we just got to find the determinant of this last matrix here. Okay? So the determinant of that last matrix will be A1 multiplied by B2, subtract A2 minus B1, and that'll be K. So that'll give some K components, so that's our Z component. Okay? Now when we calculate this, it will give us scalars. So this will be a scalar, scalar, scalar. And a scalar is just a number pretty much. So that's how you calculate a cross product. Now, the best way to learn this is to put it into action. So let's actually take a look at an example now, okay? So let's just take a look at, have a go at question 1. Determine A cross B, where A is the vector 1, 2, 3, and B is the vector 4, 5, 6. Okay? So if you want to have a go at this, feel free to pause the video and have a go, and then I'll start solving. Alright, so our solution to this question, of course, is just going to be A cross with B. So we're going to write our 3 by 3 matrix. So we're going to have I, J, K. Then we're going to take all this. So we're going to have our X component, which is 1, our Y component, which is 2, and our Z component, which is 3. And then we're going to do B. So this is going to be here. So our X component is 4, our Y component is 5, and our Z component is 6. Okay? Boom. Now let's move this here. And let's start looking at our matrices. So let's look at the X matrix. So across the first column and the first row. So our matrix here is going to be 2, 3, 5, 6 multiplied by I. Then we're going to cross out our Y component, and we're going to have a minus here because we're going to go plus, minus, when we're finding determinants of a 3 by 3. So our matrix here is going to be 1, 3, 4, 6. And we're going to have a J. And then we're going to find the determinant of our last matrix here, which is going to be plus 1, 2, 4, 5, K. Okay? Alright. Now we can calculate these little matrices here separately. Okay? So let's just start with this matrix here. So we have 2, 3, 5, 6. Okay, I. So to find the determinant of a 2 by 2, we multiply these two numbers together. So we're going to have 2 multiplied by 6 minus the product of these two numbers here, which is going to be 3 multiplied by 5. I put that in your calculator. This is going to be 12. This is going to be 15. So we're going to have negative 3i as our answer. Okay. If you have any questions, leave some in the comments and I'll try my best to answer them. So that's our first matrix done. Let's take a look at our next matrix here. So we have a negative sign, so we're going to have negative our matrix 1, 3, 4, 6. Oopsie daisy, my computer's just lagging a bit. Sorry about that. J. Where we find this negative sign at the front, the product of these two, which is 1 times 6, minus the product of these two, which is 3 times 4. And that's all J. So 1 times 6 is 6, 3 times 4 is 12, minus 12. That whole thing's going to be negative 6, but then you have to multiply it by this negative at the front, so the whole thing is going to be positive 6J. Okay? And we're almost done this first question. So all we got to do now is find the determinant of this matrix here. So we're going to have matrix 1, 2, 4, 5. Okay. So multiply these two numbers. So we have 1 multiplied by 5. Subtract 2 multiplied by 4. This is going to be 5. This is going to be 8 minus. So we're going to have negative 3k. Cool. Now what does that mean? Now that we've worked out these components. So what this means is A cross with B is going to be equal to this vector here. 3, 6, negative 3. So what does that mean geometrically? So let's say this vector is like the vector R, like we established before. That means this vector is perpendicular to both A and B. Okay, so this is the picture we've made. So we've crossed A with B and we've produced this vector R. Similarly, if we crossed B with A, we've got a vector in the opposite direction. Okay, so that's what it means to find it. Applications of the cross product is when you're finding the equation of a plane. So this is just an important algorithm to learn if you're taking any algebra or calculus course. Alright, let's take a look at question number 2. So let's just move that down there. Alright. Determine Q cross with W, where Q is 4, 2, 3 and W is 9, 0, 2. So if you don't have a go at this question, feel free to have a go and I'll get started in a second. Alright, so the solution to this one, of course, is going to be Q cross with W. So we're going to have Q cross W. It's going to be a 3 by 3 matrix. So we have I, J, K at the top. Then we're going to have 4, which is our Q vector. 4, 2, 3. Then we have our W vector, which is 9, 0, 2. Alright. So now we're going to break it up into its components. It's little three 2 by 2 matrices. So our X matrix is going to be positive 2, 3, 3, 0, 2. I guess it might get rid of that. Sorry, my computer's lagging a bit. Find our Y component, which is going to be negative 4, 3, 9, 2, J. Then we're going to find our last matrix, its determinant. So it's going to be plus 4, 2, 9, K. 9, 0, K. Alright, cool. So let's just move this, let's make this a bit smaller so we have enough room for everything. Alright, let's find the determinant of this matrix. So we're going to have 2, 3, 0, 2 I. So that's going to be 2 times 2 minus 3 times 0 multiplied by I. This is going to be 4, this is going to be 0, so we're going to have 4i as our determinant of this 2 by 2 matrix. Alright, then we're going to find the determinant of our next matrix, which is here. So we're going to have negative determinant of this matrix here. Alright, so we're going to have the negative sign at the front. 4 times by 2 minus 3 times by 9, all j. Alright, this is going to be 8. 3 times 9 is 27. It's going to be minus 27. So therefore, our answer here is going to be 19. Let me just double check that. Yep, that's going to be 19. Actually, it's going to be negative 19. That's going to be multiplied by a negative, so it's actually going to be positive 19. So we're going to have positive 19j. Alright? Cool. Alright, let's take a look at our last matrix here. So we're going to have to find the determinant of this matrix here. So we're going to have 4, 2, 9, 0, k. So we're going to multiply these two numbers together. So we're going to have 4 times by 0, multiplied by, subtract 2 times by 9. This is going to be 0. This is going to be 18, negative 18, so we're going to negative 18k. Alright, so therefore Q crossed with W is going to be the vector 4, 19, negative 18. Boom. Alright, let's go on to our last question now. If you have any questions, feel free to comment and I'll answer them. Last question of this video. Oh, we put in pi in here. That looks a bit yucky, but pi is just a normal number, so just do the same algorithm we've been doing throughout this whole video. So if you want to have a go at question 3, feel free to have a go, and then I'll start solving it. Alright, so determine h cross with r, and h is given here, and r is given here. I put in pi because I want you to get comfortable with just the algorithm, because sometimes you could be asked to find the cross product of arbitrary values, like let's say r1, r2, r3, okay, and they just gave you variables rather than constants, okay, but luckily I've still given you a constant so you can still work things out. But let's just have a go. So here's the solution. We have h cross with r. It's going to be the determinant of our 3 by 3. Our h at the top, so I'm going to negative 2, 3, 6. And then our r, which is going to be pi, 3, and 5. Alright? Break this up into its matrix. So we're going to have 3, 6, 3, 5, I. Then we're going to have negative 2, 6, pi, 5, j. Then we're going to have our final matrix plus negative 2, 3, pi, 3, k. Alright, now all we're going to do is find the determinant of this 2 by 2, this 2 by 2, and this 2 by 2, okay? So let's just take a look at this one. So we have 3, 6, 3, 5, I. So that's going to be equal to 3 times by 5, subtract 6 times by 3, I. This is going to be 15, this is going to be 18, subtract the 2, we're going to have negative 3 as our answer. Okay. Now we're going to find the determinant of this. So we're going to have negative determinant 6, 2, 6, pi, 5, j. So what's this going to be equal to? So negative at the front, then we're going to have negative 2 times by 5, then we're going to have minus 6 times by pi, j. Now this is going to be a yucky number, so this is going to be negative 10, this is going to be negative 6 pi. I don't know what that's going to be, but if we distribute the negative on the inside, we're going to have 10 plus 6 pi. So our j component is 10 plus 6 pi. Okay. And let's work out our final determinant. So we're going to have negative 2, 3, pi, 3. Okay. So this is going to be equal to negative 2 times by 3, subtract 3 times by pi. So this is going to be negative 6, and this is going to be negative 3 pi. Therefore, our product is going to be negative 6 minus 3 pi k. Alright, so therefore h cross with r is going to be equal to the vector negative 3, 10 plus 6 pi, and negative 6 minus 3 pi. Boom. Alright, that's the end of the video. If you have any questions, feel free to leave some in the comments. If you enjoyed this and learned something, like and subscribe. Anyway, thank you.